Okay, do your shout out. I wasn't expecting that kind of shout, but all right. Wow, you guys are creative. Okay, what is the largest possible area for a right triangle whose hypotenuse is 5 centimeters long, and what are its dimensions? So you're talking about a right triangle. Okay, so all you are given is 5 centimeters on this side. How do you find out the rest? How do you find out the largest area and the dimensions of your triangle?
First you do a squared plus b squared equals 5.
Yeah. Okay, so let's say this is a and this is b. Is that okay?
Mm-hmm.
So a squared plus b squared equals 5. Then what?
Maybe 5 squared.
5 squared. Then what? What's the next move? What are you looking for?
Can we solve for a variable?
Yes, let's do that. What would you like to solve for? A or B? Sounds good. So a squared equals 25 minus b squared. A equals, technically when you take a square root, there should be a plus or minus, but you're dealing with what? It's a triangle, right? You're looking for dimensions, so there can't be any negative. So here's your measurement for A. Then now what? What are you looking for? What are you looking for? Max of what? Max. What are you looking for? Max what?
Plug it into the area.
Area. Let's find the area. Area of a triangle is what? 1/2 base times height. Since I have A and B, can I use 1/2 times A times B? Perfect. You're going to need to rewrite the area back in just one variable. So area in terms of, well, we already have A solved for because Brandon said so. So guess what? This formula has to be in terms of what? B. Okay, so now that means A gets substituted with what? Square root of 25 minus B squared. Okay. So let's make this a little bit prettier. So this is really 1/2 b times square root of 25 minus b squared. Is that okay so far? Now this is the part where calculus is going to come in. Can you see that right now without a calculator? You can't do much using algebra. Okay, so all right. Oh my gosh. Now you guys are bashing the juniors, huh? All right. So we're going to use the derivative of this equation to find the critical points, okay? The reason they're called critical points is because they're so important. They're used for pretty much everything. So how do we find the derivative of this area formula? Derive it how? Product rule. All right, so let's do the product rule. I'm gonna write u prime times v, and no, you don't by now you don't have to do all of this stuff. I'm just writing it down for students who are probably listening on the video and doesn't know, okay, what side conversations are. So this is gonna give me what? What would I have here? 1/2, okay. So times 25 minus b squared. Over here, I would have a 1/2, 25 minus b squared to the what? To the what power? -1/2, okay. Don't forget the chain rule, times what? The chain rule said times -2b, and then drop down my 1/2b. Okay, let's try to make it really, really pretty. So, why don't you try to simplify that for me to see how far you can go? Did you get to at least here? Put the radical on the bottom, cancel out the 2's and the half, and it's a negative b squared on the top. Now, because you're going to have to solve this by hand, find the critical points by hand, I do recommend that you should find a common denominator. So if I were to find a common denominator, I most likely would write this on the numerator, okay, and then over 2. Then that at least you can see that there's a 2 already in common. How do you find the common denominator from here? What's your next move to find a common denominator? Yeah, on the left side, right? So if I multiply that by rad 25 to on the left side only, can you agree that on the top there's no more radicals? Yes or no? Yeah. Then I'm going to subtract b squared here, and then now on the bottom I would have this, okay? Now I'm trying to find the critical point, which means we need to set it equals to what? 0. The critical points is when the numerator equals to 0 or when the denominator doesn't exist, okay? So what's happening to the denominator? What is it that can never ever be?
0. Plus or minus 5.
Plus or minus 5. Can we agree? But because we're dealing with what? What are we doing? We're dealing with dimension. So do I even care about the minus 5? No. So on the bottom, b can never ever be 5. Now let's solve for the top. Keep on going. This is really 25 minus 2b squared equals 0. That means it's 25 equals to 2b squared. Divide both sides by 2. That's 25 over 2 equals b squared. We're about to take a root. Again, taking the square root means you should have plus or minus, but we are working with dimension, so it's just going to be 5 over rad 2. And no, you don't have to rationalize anymore unless it really helps you reduce. Okay. So here's your b. Then go back and analyze your work. This is the difficult part for these kind of questions. This. Your input, okay, so your input is a b variable. Let me ask you this. What's the domain? How large can b be? Okay, so this is where you have to really think about it. Domain for b. How large can it be? Say that one more time.
4.9999.
Yeah, can you agree that it can't be 5? Right? How come? Because it's a right triangle. It's not an isosceles, it's not an equilateral, it's a right triangle. So the hypotenuse has to be the largest. And it can't be negative either. And it can't be 0. Is that understood? So it has to be from 0 all the way to 5. Okay. Well, on the bottom, I do have b excluding 5 because that's one of my critical points, but it doesn't apply anyway. So do I have to use that point at all? No, so we don't have both. So the only point that's in between 0 and 5 is just what? 5 over rad 2. Okay, so that's the only point you have. So now what? I'm looking for the largest area and dimension. What's your next move? Plug it back in to find what variable? A, yeah. Okay, so A is, here we go. B squared, as you can see, if I were to go backwards, can you see that B squared is 25 over 2? Okay, so A is just going to be square root of 25 minus 25 over 2. Common denominator tells me, why don't you do that for me? So work that out. What are you guys going to end up with? 5 over rad 2 again. So this is going to be 5 over rad 2 again. So your dimensions are 5 over rad 2 units, or do they give you measurement? Centimeters by 5 over rad 2 centimeters, and that's your dimension. What's your largest area? How do we find that? Plug it back in. All right, largest area. Let's plug it back in. 1/2 times 5 over rad 2 times 5 over rad 2 equals. That's 25 over what?
4.
Beautiful. Okay, 25 over 4. So let's kind of put it in a box, a location with all the correct unit of measurement. Okay, largest area is 25 over 4 centimeters squared. Dimensions are 5 over rad 2 centimeters by 5 over rad 2 centimeters. Okay. Let me make it fatter for you, Mickey. I can't see either, so I get it. Okay, you try B. I'll put like a couple minutes for you to work out B. How far can you set it up on your own?
Give it another minute and then we can converse. You guys have less than a month left of school. When is first period finals? Thursday? Wow. Last day of school, you're gonna come in here and take your calculus final exam?
Yeah, I thought it's the week before for the senior final.
Yeah, but you guys don't have enough time to review. So my senior will take it that Thursday, Friday, but you guys probably want more review time.
Doesn't take it 2 days in a row.
They will, because they don't have a block day for those.
Is it gonna be on computer again?
I don't know if I can get one, because I don't have my own. So I have last dip on Chromebook. It goes priorities, algebra 1, geometry, algebra 2. And then whatever days left over is
We're
my
like the best.
We are the best.
Exactly.
We should. We are definitely the best. But, you know how it goes. The higher math you go,
The less. Yep. Because I just figured you guys already know it, you know? Yeah, because I handle it on your own. Okay, why don't you talk to one another? And then we'll go over the answer together, okay?
4 meters squared.
Don't forget dimensions as well.
The largest possible, yeah. 2 meters.
now, on the homework, obviously you can always use a calculator to verify your work. But this is just,
Huh?
The test that did this stuff?
Yesterday?
No, the test that,
Derivative?
no, like
What?
the first test of the year.
Oh, the first test of the year.
The only test I did.
A maximum, minimum? That means you're going to do well on this. Because it's the same stuff.
Yeah.
Yeah.
I like know this.
Yeah, see? Are you excited? It comes full circle.
I got 90.
Okay, so I'm going to write the answers first and see if we can do it. What is the largest possible area? So largest area. Okay. So, Ian, what's the largest area you got, bud?
Somehow managed to get negative, so.
Well, that is kind of impossible in areas. So why don't you try that again? No. Emma, don't just work with him. Not just, oh my gosh.
As the air somewhere, that means
That's right.
Here.
You got a negative area. Oh my god.
Did you get? You have to plug this into the H.
Okay. What variable did you guys use for your rectangle?
L times W.
Okay, W, L. Largest possible area. So area, it's always length times width, right, y'all?
Yes, ma'am.
Perimeter, they gave you the perimeter already, which is 8 meters, which is really 2L plus 2W. What variable do you guys solve for? Pick a variable.
L, no, W, because we take them.
Okay, so that means I'm going to move the 2L over. So 8 minus 2L equals 2W. Divide everything by 2. So 1W is equivalent to 4 minus an L. Yes, no, maybe? And either way, you're going to get the same answer. Does not matter what variable you're going to solve it for. So your area formulas in terms of what variable? A of what? L. Yeah, you got to know. All right, is because you have to know the domain. That's why it's important. So every time I see an L, I'm going to write down 4. Sorry, every time I see a W. W is 4 minus L. Okay, which I need more space. So A of L, sorry, write that over again, which is 4L minus L squared. Yay, nay, maybe? Yay! Let's do the derivative and find the critical points. The derivative of the area in terms of L is 4 minus what? 2L. Set equals to 0. L comes out to be what? Dose. Okay, now let's check the domain. Again, always go back and check the domain to see if it makes sense. If your total perimeter, y'all, it's 8, what's the most that each side can be?
2.
You guys agree?
Yes.
Because, so let's talk about what if they're equal? Then they have 4 sides, right? Yes or no? Okay. I know that it can't be 0. It can't be negative. What's the most it can be? Can it be 8? Can be like, can a length be like 7.5? How small would the other ones be? Yeah.
0 to 4.
0 to 4.
Is non-inclusive.
Yeah, because you have to think about this. First 8 has to divide by 2 because they're 2 exact equivalent sides. Is that understood so far? But keep in mind, couldn't one of the width or one of the lengths be like a half or a quarter or an eighth, right? It can be very, very small as long as it's not 0. So would you agree that 8 divided by 2, it's up to 4 units? Okay, so your domain, one of the lengths or the width can only be from 0 to 4. So when you solve for L, is it within the domain? Which means you can keep it. So now you got L. W is also, what's W? Also what? 2. Okay, so we got those. What's the largest area? 4. So largest area is 4 meters squared. Dimensions are 2 meters by 2 meters. Okay, so those are them. So always check your domain to make sure it makes sense in the context. All right, let's move on to example 3, because guess what? You did example 2 last night, but let's go and fill out the strategies for on page 27. Am I going too fast? No. Not fast enough. All right. Request to speed up. Okay. He's excited. All right. All right, let's go. Strategies for solving max-min problem. There looks like 6 of them. Understand the problem. Look at that. Understand the problem. Obviously, that seems like common. Do is, you want to read it? Okay, read it again. Okay. Oftentimes, what you need to do is identify what you have, what you are given. Okay, or aka the facts that I give you. Okay. And what you're trying to find. So even at myself, when I work out your homework, oftentimes I don't know what they're trying to find. So I draw a picture, take a piece of paper and really fold things up to see what they're really trying to look for, okay? So 2, that's exactly what we're going to try to do. Draw pictures. Draw pictures, okay? Label all parts using variable. Okay. Label all parts using variable. Just like what we did with example 2 when it talks about a parabola or a circle inscribed in a parabola or a rectangle inscribed in a parabola, you want to graph them out. Okay? Graph the given function. And find the applicable domain. Let's put range in here as well, because oftentimes the range is the area or the perimeter. Those cannot be negative. Okay, so you make sure we understand what it cannot be. Okay, next we're going to need to find the critical points and also the endpoints. Okay, so identify critical points / endpoints. Then number 5, solve the problem, check your result with a graphing calculator if possible, or check it with another method, okay, if there's, obviously, if you have time. So solve the problem. Check your result with a calculator if possible. Also another method if possible. So when I do derivatives, okay, I want to do a couple of different ways to make sure they all come up with the same answer. Last one is you need to interpret your solution, okay, to make sure it makes sense. If it's talking about max and min, then you want to put in the correct unit of measurement. All right, let's go to example 3 and 4, and that's the end of my day. 5 and 6 is on tonight's video, so you can start right away, or you can just wait until you get home. Here we go. Can you help me? Nina, help me read example 3A, please.
A 216 squared rectangular p-patch is 2 enclosed by fence and divided into 2 equal parts by x to one of the sides. What dimensions for the outer rectangle require smallest total length of fence? How much fence will be needed?
Perfect. What should you do? Yeah, one of the strategies says draw a picture. We should draw a picture, okay? I have a rectangular p-patch. Now what? Divide it. It says divide to equal parts. So, okay, now what? What's the next step?
Label.
Label. Okay, what variable should we use? X. Sounds great. X is the base or the height? Or base or length? Base. Okay. So this is X down here. What's the width, or what's the length, or the height, whatever you want to use it? What's the other variable? Y, perfect. How many Y's technically do you have?
2, 3.
3. Can you see why you have 3?
Wait, do we need the fence to go around the entire thing and the middle?
It said so, right? It says there you are making just a rectangular pea patch that is enclosed by a fence. And in the middle, you are dividing it using another fence. Okay, now what? What are you trying to find? Max? Maximum area? I'm trying to find how much fencing, right? So when you're using material, you want to use the most possible? You want to use the least possible? Probably the least. I want to save money, okay? I'm cheap. So, now what? Okay, you are given, just like one of the strategies said, hey, write down the stuff that's given to you. The area is 216 meters square. What's the formula for the area? X times Y is correct, okay? But I'm looking for perimeter, right, y'all? Perimeter and some, okay? Perimeter, that's part of it. Also the extra fence. So let's talk about the perimeter. How much perimeter do we have? How many Y's, how many X? 2X, 2 Y's, that's the whole perimeter. But there's an extra what? Y. So can I write 3? I wouldn't say perimeters, right? Can I just write fencing? Because that just like...
Wouldn't the extra Y not factor into the area of the pea patch?
Well, the area doesn't change, right?
But if we solve it with 3Y, then we're going to have shorter.
That's what I'm saying.
I'm looking for how much fencing I would be using to divide this garden up.
But can we just solve for the area and then just use our Y value and say that's the...
Oh yeah, you still solve it the same way. That doesn't change really. Okay, so what variable do you want to solve for? Pick one. Pick anyone. Y. Okay, so Y equals 216 divided by X. So over here, your fencing is in terms of what variable? X. Okay, so every time I see a Y, 3 times 216 all over X plus 2X. Okay. Someone give me 216 times 3 is what? 648. Equals 648 over X plus 2X. Okay. I don't need to make this pretty because I'm about to do what? I need to derive it, right? So go ahead and do F prime for me. Okay. Do F prime for me. What would you get? You can do quotient rule. Oh, thank you, Nina. You can do quotient rule, or can I move that up to be a negative power and do a power rule? Yeah, it's really up to you. So once you have the derivative, you let me know what you got. Does this look about right? Yeah? Now what? Common denominator? Sounds good. So that means I'm going to have negative 648 plus 2x squared all over x squared. Let's talk about the restriction of x. Okay, I'm about to make this equal to 0 because I need to find the critical points. But would you agree that x can never ever be 0?
Yes.
That makes sense anyway because x is one of the sides, right? And that can't be 0 anyway. So let's go back and talk about the domain. I know it can't be 0, so it's going to be greater than 0. But how much? How high up can it go? Uh-huh.
To 108.
To 108. How did you figure it's 108?
You divide 216 by 2.
216 divided by 2. Let's talk about, remember, it's the area is 216. Area is length times width. Can I have, let's say, can I have x being 1/6 or 1/2? Can x be 1/2?
Oh.
Yes or no? Can x be 1/2? If x is 1/2, would the other side be more than 108? So how high up can you go? Can I have x be 1 over what 2/16? Or
0 to 54.
0 to 54. Let's talk about this. How do you know what's the most? What if x is like 1/2? What's the y? Let's just talk, like plug in some number just to get a feel of it. 532. Would that be okay? Is that okay? Can x be like 1 over like 100? It could be. So would you agree that there's no really, in essence, there's no max in terms of what y can be in the context of numbers? Is that okay? So for this one, I have a minimum domain, but x is really, the max is really in question, right? As long as I don't have a negative number, I'm going to be quite okay. So we're going to solve for it. I can't have x be 0 anyway, so I'm going to ignore this altogether. I'm not going to use it as one of my critical points. How do you solve for the numerator? What would you do here? Would you have 2x squared equals 648? Divide both sides by 2. What's 2 divided by? What's 2 go into 648? 3, 24. I need to take a square root. Is that going to give me a nice number, guys? 18? Oh, nice. Technically, it's plus or minus 18, but I do not care about the negative. All right, you got 18 for one of the x's. Okay, let's go back and do what? Plug it in. Okay. I need to find y, right, y'all? Y is 216 divided by 18, which is, someone give it to me, 12. Thank you so much. Okay, so I got my dimensions, but then I also need what? How much fencing? So let's plug it in. Every time I see a y, I'm going to plug what in? 12. Every time I see an x, I'm going to plug what in? 18. Work that number out for me, please. How much fencing would I need? What is it? 72 meters total? Okay. All right. So let's write our answer right here on the bottom. Fencing needed. Okay. 72 meters total. There's not a square on it because it's not an area. Dimensions are, we have 12 meters by 18 meters. Okay. So that's that.
Does it matter if you put 18 by 12 or 12 by 18?
No, it doesn't matter. Yeah. So like even if we do it with volume, you can do length by width by height or any way around.
Okay.
Okay, am I going too fast? Okay, you try B. This is slightly different because of what? This is like one of your earliest test questions. Remember the river problem?
once you are stuck, or once you have an answer, you consult with your people.
That sounds right.
Did you guys draw a picture? Yeah. I'm such a visual learner though. What variable do you guys use? X and Y again? X on the bottom? Okay. You guys need more time? No? Done? Okay. Let's go backwards. Why don't you guys give me the answers first? Largest area. Largest area. What did you find for largest area?
500.
500,000 meters square. Someone confirm that for me?
Yeah.
And then your dimensions are, what are your dimensions? 1,000 meters by 500 meters. Okay. Someone confirm? Yeah. Okay, so let's see. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders a highway. If the farmer does not fence the side of the highway, along the highway, what dimension will be enclosed? Will enclose the largest area. What is the largest, area? I'm missing an A. That can be enclosed. So again, the largest area, the common theme is really X times Y, which I'm going to have to solve for that soon. You have fencing, that's technically perimeter, yes or no? Except that your perimeter only has 3 sides, right? So 2y plus an x, and that's going to give me 2,000 meters. What did you guys solve for, x or y? Seems like easy to solve for x, right? What do you guys solve for? Yeah, because it seems like I just have to move the y over. So 2,000 minus 2y. So that means your area is of what variable? Y, okay. So equals, every time I see an x, x is going to get replaced with 2,000 minus 2y times a y. I would definitely distribute that out because I'm going to need to take the derivative. So that's 2,000y minus 2y squared. Is that okay so far? Now let's do the derivative. A of y, a prime of y equals 2,000 minus 4y. Yes or no? Solve for zeros. I'm sorry, solve for y. So 2,000 equals 4y. Y came out to be 500. So that's where the 500 came about. Once you have a y, what do? Plug it back in. 2,000 minus 2 times 500. X is going to come out to be 1,000. And then just take those two values. Yes?
That doesn't make sense because he's trying to enclose the largest area and you have an x value of 1,000.
Sure. This is 1,000. This is 500.
Differently.
What did you do, bud?
I drew the vote on the left instead of on the top.
It doesn't matter. By the way, you can draw the river any way you want. I promise you. Okay? The river can also be over here, or the sideway. It doesn't really matter. You're still going to have whatever variable you use. Okay? You're still just going to have 2 of something and 1 of the other. All right. This is an egg roll, because I'm not going to start example 4. I don't have enough time. Tonight's homework, example 5 and 6, and then tomorrow we'll finish example 4 in class.
Last time you say that, we should have like an egg roll.
I bring egg rolls to the
Yeah,
finals?
that's true.
Oh, finals. Like me the day before the finals. Like so that way, finals. You guys. So finals, you want to concentrate.
What if I'm like getting a little hungry in the 2-hour final?
Yeah, it's like
Egg
great
roll.
food, right?
Okay, you can bring egg rolls.
Can we have an egg roll party though? That's the question.
An
When I
egg roll
finish,
party,
Matt
not
will
a
be
party
there.
on your final day, because that's going to be distracting. Thank you.
No, when everyone finishes though, we just get an egg roll.
I do love egg rolls. I don't know how to make them, but I do.
Jeez, good luck on this.
Oh my god.
Nah,